All right. So today we are going to learn about how we will going to use these tools to solve a few programming problems. Now we have already discussed about how to implement these tools in our previous classes. But in this particular class, in this particular lecture, we're going to understand how to utilize these tools. Okay. So before we begin, we need to go through the tools that we have presently at hand. Okay. So the first tool is check composite. Now this particular tool or a function, I'm going to use these terms interchangeably, tool or function, is going to check whether the number passed in is a composite number or not. And accordingly, it's going to return true or false. Okay? I'm not going to explain how the tool is written as it has already been discussed in the previous class. I'm just going to quickly go through the tools that we have at hand. Next tool is factorial. This tool is used for calculating the factorial of the number that is passed within the function, and it returns an integer value as the result. Next tool that we have is called power, and this is used for raising a to the power b. It's used for calculating a to the power b. All right. Now, as a result, it will return an integer because while writing this particular program, we took this particular assumption that A and B are going to be natural numbers or whole numbers. So for that matter, B is going to be a whole number, whereas A is going to be a natural number. Right? The next tool that we have is check prime. And this is going to check whether the number passed in as argument is prime or not, and accordingly it is going to return either true if the number is prime and false otherwise. Next tool that we have is print digits. Now, in most of our programs, we are going to utilize this tool or rather modify this tool to suit our needs. What this tool presently does is it prints every single digit of a number that is passed in as the argument. It does not return anything, hence the return type is void, but it simply prints out the digits present within the number. Right? Next tool that we have is count digits. Now, this particular tool is used for counting the number of digits that we have in a number. Let's say we pass in the number 1729 as argument to this particular function. Now, what it's going to return is 4 because it contains 4 digits in the number. The next tool that we have is quite similar. The tools that I'm discussing presently are quite similar. The code is quite similar. We just need to change a line here and there. The next tool we have is sum of digits. And this tool is going to help us to calculate the sum of digits of a particular number. So if we pass in 1729 as the argument, then it's going to calculate the sum of the digits. And that's 19. 9 plus 1 is 10 and 7 plus 2 is 9. So 10 plus 9, 19. Next tool that we have is for reversing a number. So let's say we pass in 1, 2, 3, 4 as the argument, and the return number will be 4, 3, 2, 1. Right? That's what this tool does. So that's much about the tools that we have at hand. And using these tools, we're going to solve the problem that I'm going to discuss right now. For example, the first problem that we're going to solve is for Armstrong numbers. Right? Okay, so let's quickly run this program and let's see a few sample outputs. All right. So if I call check composite with 5, I'm going to return, it's going to return false. And if you go check with 6, it's going to return true. And for 5 factorial, it's going to return 120. For 3 comma 2, that's 3 squared, and it's 9, it's going to return 9. Check prime 3, 3 is a prime number, hence it's going to return true. 9 is a not prime number, and hence it's going to return false. Now, if we call print digits on 1729, then it's going to print the digits in a reverse order. It doesn't matter. We don't need to print it in the normal order. We can do this. We can get away doing just this. Okay? Next, count digits is going to return 4 if it contains 4 digits, and if the number contains a single digit, it's going to return 1. Sum of digits on 1729 would return 19. The reverse of 1729 is 9271, and the reverse of 1234 is 432. I hope that's clear. That's all clear. And next, we're going to start with Armstrong numbers. All right. So the question for Armstrong numbers goes as follows. A positive integer is called an Armstrong number of order n if a, b, c, d, dot, 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 this is a number. This is a generic representation of a number. If this can be written as this, meaning that every digit is raised to n, and then if the sum is considered, and if it's equal to the original number, then it's called an Armstrong number. And n here is the number of digits present in this number. Let's take this example and let's break it down. Take down this example. Okay? Okay. So we are given a number which is 153. Now, even before we start computing the sum, we need to first find out the value of n, meaning the number of digits that are present in the number. Now, 153 contains 3 digits, right? Next, what we do? Next, we extract every digit of this number and we raise every digit to n and find that sum. So, first we're going to have 1 and we're going to raise it to n, that's 3. Then we're going to have 5, we're going to raise it to power 3. Then 3, we're going to raise it to power 3. And ultimately, we're going to end up at some sum. And consequently, that sum is 153. Now, because the original number and the sum are equal, therefore, we can conclude that the number is an Armstrong number. Otherwise, it is not an Armstrong number. Not an Armstrong number. And that's exactly what we have been asked to do. We have been asked to ask the user for a number and check whether the number is an Armstrong number or not. Now, if you paid attention just before I began explaining this question, you would understand that out of the tools that we have here, we would need to use the tool count digits, right? And in addition to count digits, we have to use print digits, which we are going to modify, all right? So the tools that we need to use would be count digits and we will need to modify the existing print digits function. Now, why print digits? You see that print digits prints out every digit of a number that is passed in as the argument. And while finding out the sum, we raise every digit to some power. So as the operation is being done on every digit, it makes sense to modify the print digits function, which accesses every individual digits of a number. Okay. Let's get on with the program and see how this is done. All right. Let's create a new class. Let's get a random gibberish name. Okay. At the very beginning, we're going to take the number as input. You import the scanner class. I'm sorry. The class would be Armstrong. To make our code a little faster, to write the code a little faster, I'm going to copy and paste these tools. So we're going to need this tool, count digits. Let's paste it here. And then we're going to need the void print digits. We're going to modify this to check whether a number is Armstrong or not. Okay. Now, because we're checking whether a number is Armstrong or not, it makes sense to change the return type to Boolean. Now, instead of print digits, I'm going to change the name of the function to check Armstrong. And it's going to take a number as an input, as usual. And I'm going to keep this while loop for a bit. We're going to see how this while loop will be changed. Now, the first order of business is calculating the value of n, or the number of digits that are present inside that are present inside the number. Okay. So that's the first order of business. Calculate the number of digits in number. Now we don't need to write a loop all over again. Why? Because we already have a tool at our disposal which does the exact same thing. So I'm going to take it as n because that's how the problem was described and it would be easier for you to correlate. So for calculating n, we're going to call this function. Now, if you go through your copy, you're going to see that for calling a function, there were two methods of calling a function. One, or calling a function from inside a method, from inside the main method, and calling a function from any other method except main. Now, this is the second situation where we are trying to call a method from the method which is not a main. So in case of this, we call a method simply by writing the name of the method and passing in the argument. So in the end, we're going to have the number of digits present in num. Now, after we have that, we need to calculate this particular sum, right? Now, to do this, let's declare a variable. Let's initialize a variable called sum, which is going to have the initial value as 0. So int sum equals 0. Now, we said that we're going to modify this particular method, this particular while loop. Now, we don't need to print out the digit anymore. We need to do something with the digit, but we don't need to print out the digit anymore. If you see here that every digit is going to be stored in a variable named dig. Now, for calculating this to the power 3, we're going to need to write a small Java code, right? So if we need to raise dig to the power of num, how should we go about doing that? Well, that can be simply done using the math.power function. So we have dig as a variable and n as another variable, and we need to calculate dig to the power n. Now this can be written in Java as follows: math.power dig, comma n. Now there's one caveat in this. The thing is, math.power always returns a double, but we know that raising a whole number to another whole number would always fetch us an integer, right? So therefore, what we need to do is we need to typecast this value to an integer, because the sum that we are going to calculate is going to be an integer. It's not going to be a double. Therefore, for calculating dig to the power n, this is the expression that we are going to use, right? So let's come here and let's calculate that power first. So int dig underscore n, and this we're calculating this by writing int math.power raise dig to the power of n. Right? Now after this, we're going to add this dig underscore n to sum. Okay? The other way around. But you see, there's going to be a problem. What is the problem? Because after calculating the sum, the next step that we need to do is we need to check whether the original number is equal to the sum. But after this loop terminates, num is going to be 0, right? Therefore, what we need to do is we need to store the num in a temporary variable such that the original number is not lost. I hope you're clear on this, because you see, after the loop terminates, num is going to be 0, because that's how this loop is going to terminate, num not equal to 0. So by doing this, eventually the value of num is going to be 0 and we're going to lose the original number. Hence, what we're going to do is we're going to store the original number inside of a variable called temp. Now, after we have calculated the sum, let's quickly put a comment here, calculate the sum. Next, we're going to check if the original number is equal to the sum that we have just calculated. Now, the original number is no longer going to be stored in num, it's going to be stored in temp. So temp equals sum. That is so. We're going to return true. It's return false. Right? Now, instead of writing this big if-else statement, this can simply be converted into a single return statement as follows: return temp equal to sum. But if you have trouble understanding this, you may go for this. This is commented out because this is an alternative. Right? You may go for either of them, but you cannot write both of them. Right? You may either go for this or you may either go for this. Right? Now, 80% of the job is done. Next, we need to write our main method, inside of which we're going to call the check Armstrong with the number that we have taken as input from the user, and accordingly we're going to display the message whether the number is Armstrong or not. So public static void main args scan system. And next, what we're going to do is we're going to create an object of this class because we need to call these functions. Not these, just this function. The first we need to take a number as an input. System.print enter the number. Print num instant. Remember, some of you might have a problem that why have I used num here? Because that the num has been used in this function, has been used in this function as well. The thing is, this is a local variable, and the scope of this variable is inside this brace. Because the scope of this num, because the scope of this brace and this brace does not conflict, does not overlap, therefore we may use the same named local variable in two different blocks. Right? It doesn't pose any problem. It doesn't cause any problem. Right? Now, after we have taken the number as input, what we need to do is we need to check if the current number, the present number, is Armstrong or not. Now we do that by calling this function. Remember, we do not need to call count digits because check Armstrong will internally call count digits on its own. We need not call it separately. Right? We're going to call the check Armstrong function. So if obj.checkArmstrong, because this is a member method and hence we're going to use the object representation, call the function check Armstrong. And then inside of this, we're going to pass in the number that we have taken as input. If the value of this is true, then we're going to return, not return, we're going to display system.out.print. Sorry that I'm making a ton of mistakes today. I'm really not well. I'm a little disoriented. Today. Please forgive me. It is number else is not an Armstrong number. Let's compile this program. Class compilers and English. Well, me. And let's run this program. Okay, so the number that we will test first is 150, and it is an Armstrong number. Let's search the internet for some other examples of Armstrong numbers. Armstrong numbers. Okay, so 9474 is another Armstrong number. See, that's an Armstrong number as well. Let's run this program with 9475. I don't think that's going to be an Armstrong 5, and it's not. So that's about it for our Armstrong number checking program. In the next video, we're going to learn how to generate Armstrong numbers within a range. That's pretty simple. We're just going to modify this particular class a little bit. Only the things inside of main method is going to be modified for us to write that program, generation of Armstrong numbers within a range. Okay. Hope to see you in the next video.